Hey guys, my name is Davey from Eazyrob Learning, and today we'll be talking about the molecular structure of water and its importance in living organisms. By the end of the day, you should be able to describe to me the molecular structure and boiling of water, and also understand how these attributes contribute to living organisms and their survival on the planet. Right, let's begin with the structure and boiling of water. Water is a simple biological molecule making up about 70% of the human body. It is simply made up of a covalent bond between two hydrogens and one oxygen atom, as seen in this bond in this drawing. As the oxygen atom is much larger than the hydrogen atom, what you have is that the bonding pair of electrons are more attracted towards the oxygen atom than they are towards the hydrogen atom. What this causes is that the oxygen atom is relatively negative, whilst the hydrogen atoms are relatively positive. This can be written as a delta negative and a delta positive, as seen in this drawing below. Right. Due to this impartial sharing of bonded electrons, water can be said to be dipolar, meaning one side is slightly positive, whilst the other side is slightly negative. And this can contribute to a formation of weak interactions within water molecules, same as how dipolar molecules have weak interactions within themselves. In the case of water, these interactions are called hydrogen bonds. In an exam, you might be asked to draw the hydrogen bond in between two water molecules. Ensure you draw the water molecule properly, that means two hydrogens and one oxygen, and draw the hydrogen bond as a straight dashed line between the hydrogen atom of one molecule and the oxygen atom of another molecule. Do not forget to add the delta signs, as you may lose marks if you don't. Right, let's start discussing the properties of water. Firstly, water has a high specific heat capacity. This means that it takes a lot of energy to increase the temperature of water. This is because of a lot of energy is required to overcome these hydrogen bonds that we are talking about earlier. Due to this high specific heat capacity, water can act as a temperature buffer, keeping a narrow temperature range required for enzymes and other chemical reactions to occur in eukaryotic and prokaryotic organisms. These reactions can occur optimally because of this narrow temperature range. Secondly, water has a high specific latent heat of evaporation. This means that it takes a lot of energy to increase the temperature of water to its boiling point. Because of this, water can act as a coolant. I say this because once water evaporates from an area, it leaves the area cooler than what it was before. This is particularly useful in organisms that sweat. When an organism sweats, their body temperature evaporates the water on their skin. This leaves the body temperature cooler than what it was initially. Furthermore, because of water's dipolar nature, it can act as a solvent to many substances, especially salts. This can occur due to the positive regions of water interacting with the negative regions of a solute, i.e., negative ions, and the negative regions of water interacting with the positive regions of the solutes, i.e., positive ions. Because of this property, water can act as a transport and chemical medium. Evidence of this can be seen in the blood and in the cytosol. Finally, water has some cohesive properties due to the hydrogen bonds between water molecules allowing water to move as a singular mass. This allows this allows plants to draw up water from their roots. Furthermore, water has some adhesive properties. This means that water molecules are attracted to one another or are attracted to other materials, forgive me. This is particularly useful in water molecules being attracted to the xylem of plants, aiding capillary reaction. Right. In summary, water has a high specific heat capacity and high specific latent heat of evaporation, thus allowing water to have a temperature regulatory role and cooling effect respectively. Water's dipolar nature also allows water to act as a transport mechanism and a chemical medium. Finally, water has some cohesive and adhesive properties that are particularly useful in the capillary action of plants. I hope you enjoyed this session. Thank you.